Hello, my dear students in grade 9. This is a new mathematics lecture, and the title of our lesson is Algebraic Expressions or Polynomials. What are we going to do in this lecture? Objectives. Number one, how can we solve a first and a second degree equation? The second degree equation, which we call the product equation, these are revision from last year. And as a reminder of what we are doing in the class, we will solve together an exercise. First, solve a first degree equation. You know, when we talk about a first degree equation, this equation has a variable which is x, and the exponent of this variable should be 1. To solve a first degree equation, the rule says all variables should be on side 1 and all numbers on side 2. When we take from side to side, change signs, positive to negative and negative to positive. The equation should be written in the simple form, which is ax equal b. The solution or the root is x equal b over a. For example, if you have 3x equals 6, this is a simple form. So directly I get the solution x equals 6 over 3, then x is equal to 2 is my root or my solution. If I have an equation 2x minus 5 equal 4x plus 3, as the rule says, all variables to side 1, all numbers to side 2. When we take from side to side, we change signs. So 2x is on side 1, so I keep it on side 1. 4x is on side 2. I want to take it to side 1. It's positive, so when we take it to side 1, it becomes minus 4x equal. 3 is on side 2. I keep it. I bring minus 5 to side 2. It becomes plus 5. I calculate side 1. 2x minus 4x is minus 2x, and 3 plus 5 is 8. Now it's in the simple form. So the solution x equal 8 over minus 2, then x is equal to minus 4. When we are solving a first degree equation, we might get special solutions. Suppose you have an equation written in the form ax equals 0. For example, 3x equals 0, 5x equals 0. Then directly the solution is x equals 0. If we have this form 0x equal b, for example, 0x equal 5, 0x equal 7, 0x equal minus 3, directly I say x has no solution. 0x equals 0, then x has many solutions. These are the special solutions of a first degree equation. Now, how can we solve a second degree equation? To solve a second degree equation, this equation has exponent 2. How should a second degree equation be written? It should be written in the form of a product equation. The product equation is either ax into bx plus c equal to 0. Always on side 2 we should have 0. Side 1 might be a monomial multiplied by a binomial, or on side 1 we might find a binomial multiplied by a binomial. Also on side 2 we should have 0. Examples. On the first one, for example, if we have 2x into x minus 3 is equal to 0, then 2x is equal to 0, so x is equal to 0. This is a special solution. And x minus 3 is equal to 0. We take minus 3 to side 2, then x is equal to 3. So it has two solutions, x equals 0 and x equals 3. Another example, x plus 2 into 2x plus 4 is equal to 0. This is a product equation. On side 2 we have 0. Side 1 is written factorized. This form, we call it the factorized form. So how can I solve it directly? Either x plus 2 is equal to 0, then x is equal to minus 2, or the second binomial 2x plus 4 is equal to 0, then 2x is equal to minus 4. This is a simple form equation. So x equal minus 4 over 2, then x is equal to minus 2. If we are given an equation to solve, it might be a first degree or a second degree equation, as we said. To solve a first degree equation, we make it in the simple form, all x on side 1 and all numbers on side 2. To solve a second degree equation, side 1 should be in factorized form and side 2 should be equal to 0. Example, 2x plus 7 is equal to negative 3. This is a first degree equation since x has exponent 1, all variables to side 1, all numbers to side 2. So 2x is equal minus 3 minus 7. Then 2x is equal to minus 10. This is a simple form. X is equal to minus 10 over 2. Then x is equal to minus 5. 3x squared minus 5x is equal to 0. This is a second degree equation since x has exponent 2. Side 2 should be 0. Side 1 should be in factorized form. Is it factorized? No. What's common between the terms x? So I factorize it. X into 3x minus 5 is equal to 0. So either x is equal to 0 or 3x minus 5 is equal to 0. Then 3x equal 5 and x is equal to 5 over 3. It has two solutions. X squared minus 25 is equal to 0. This is a second degree equation. Side 2 is 0. Side 1 is not factorized. So we factorize it using remarkable identity 3. This is written x minus 5 into x plus 5 is equal to 0. So either x minus 5 is equal to 0, then x is equal to 5, or x plus 5 is equal to 0, then x is equal to minus 5. Let me continue. Then x is equal to minus 5. Now x squared minus 6x is equal to minus 9. So this is a second degree equation. Side 2 should be 0. So minus 9 should be taken to side 1. It becomes plus 9. X squared minus 6x plus 9 is equal to 0. We factorize this using remarkable identity 2. So x minus 3 all of its square is equal to 0. This is a double solution equation. X minus 3 is equal to 0. Then x is equal to 3. A second degree equation, as you can see, always has two solutions. Here it has a double solution. Now I will continue. As a reminder, I will solve with you an exercise. Given a polynomial p of x equal 3x minus 2 into x plus 2 minus 3x minus 2 all of it squared. Question number 1, develop and reduce p of x means we should get rid of parentheses. Here we get rid of parentheses by multiplication. Here we apply remarkable identity 2. After we do all the calculation, I get the expanded form, which is minus 6x squared plus 16x minus 8. Now in part B, calculate P of radical 5. So I should get the numerical value of P of x for x equal radical 5. I replace in the expanded form. So I replace each x by radical 5. This is my answer. Then question number 2, we should factorize P of x. To factorize P of x, we should find a common factor between the terms, which is a binomial 3x minus 2. And we open bracket from term 1, we should have only x plus 2 minus 3x minus 2. Now we get rid of the bracket and we calculate. Now, solve the equation P of x equals 0. To solve P of x equals 0, we take the factorized form. So 3x minus 2 into 2 minus 2x plus 4 is equal to 0. Either 3x minus 2 is equal to 0, then 3x equal 2. So x equal to over 3 is the first solution. Or minus 2x plus 4 is equal to 0. Minus 2x is equal to minus 4. X is equal minus 4 over minus 2, then x is equal to 2. Part number 3, solve P of x equal minus 8. Since here it's equal to a number, we take the expanded form. So minus 6x squared plus 16x minus 8 is equal to minus 8. Side 2 should be 0, so we take everything to side 1. Now minus 8 and plus 8 is equal to 0, so minus 6x squared plus 16x is equal to 0. We should factorize side 1. We take a common factor x into minus 6x plus 16 is equal to 0. So either x is equal to 0 or minus 6x equal to 16, then x is equal to 16 over minus 6, and x is equal to 8 over minus 3. This is what we are doing in class. Please solve this exercise well on draft, and if you have any question, please contact me. Thank you.